Let's answer the Z-Table video practice questions. Okay guys, at the end of the video, learning to use the Z-Table, I asked 3 questions that I thought would be good practice questions. In the first one, I proposed that we would have a distribution or a population with a mean of 10 and a standard deviation of 1.8. And the question was, what was the proportion of this distribution, or this, you want to think of it this way, the population that would be found between, let me fix that, 10 and 13.3. You could also read this as, what is the probability of randomly selecting a score from this population or distribution that was between 10 and 13.3. So what we're going to do is get the z-score of both of those boundaries of our interval that we're solving for. So the first one, this is going to be pretty easy. 10 minus 10 over 1.8 gives us 0. So the z-score of 10 is 0. 13.3 is the other boundary edge. So we're going to solve for that. 13.3 minus 10 over 1.8. So when I solved that, I got 1.83 repeating. Now, the table that you're looking at, it's probably like mine, it only reads to 2 decimal points, 2 decimal places to the right of the decimal point. So instead of 1.83 repeating forever, we're just going to go with 1.83. That's what we're going to look up on the table. So naturally, I did that. Let me draw you a picture of what I found. Let's keep both those scores. I'm erasing, but you can hold on to them. Remember, we have a distribution that looks like this. With the mean in the center, that's a z-score of 0. That's what the mean is. And the area to the left of that is 0.5. This is an arrow. So that is 0.5. That's half. And then our second point is at 13.3. The z-score there was 1.83 repeating. I'm just going to go with 1.83. When I look that up on the table, I find that the area to the left of that, and I'm going to use horizontal lines to cover this entire area. So the horizontally lined area is, horizontal lines, 0.9664. So in order to solve for the area in between, I have to take this larger area that we solved for, 0.9664, and subtract the smaller area to the left, which is what I do not want to be left with what's in between, which is right here. That's what I want. So I'm going to subtract 0.5 from 0.9664, and I get, for this, let me find some space, 0.4664. So the proportion is 0.4664, or 46.64%. So that's the answer to the first question. In the second question, I proposed a distribution that had a mean of 122 and a standard deviation of 14. And now we're trying to find the area of that from 100 to 118. Now this is a little bit different. It's kind of interesting because I think we're going to find that both of them have negative z-scores. Why? Because they're both to the left of 122. Let's go ahead and solve and see what we get. Okay, 100 minus 122 divided by 14, I got a z-score of negative 1.57. Again, I'm truncating that, rounding it because I want to use the z-table. Solving for 118, I have 118 minus 122 divided by the standard deviation, and that gave me a z-score of negative 0.286, right? Again, actually, I truncated that more and used, I should say, negative 0.29 when I looked it up on the table. So when I looked it up on the table, the area that I got to the left of, I'll make a little space, the area that I got to the left of negative 1.57 was and we'll make that right there. This area was 0.0582. And the area to the left of negative, let me mark that. The area that I got to the left of negative 0.29 was, let me fill that in to make sure it's clear exactly what area we're talking about. The horizontal lined area was 0.3859. So again, I've got this larger area, 0.3859. That's the whole larger area. And then I've got this small area to the left, the tail, of 0.582. I subtract them, and the answer is 0.3277. So that's our answer for the second question. Make sure you got the same result when you did it. For the third question, our mean was 40, and our standard deviation was, what did I put? 6. And the question, I'm going to draw a picture. Here's the mean. The question was, what is the proportion of the distribution greater than 10 units from mu? So that takes a little interpreting. Greater than 10 units from mu. Okay, so a lot of times the confusion in this sort of question will come from the fact that people don't know what the 10 really means. 10 what? Well, if you get a question like that, because it can be seen as being kind of vague. If you get a question like that, the question means to ask you in the same units that are being used to specify the mean and the standard deviation. So we have to find 2 points that are 10 units away from mu. A little thought, and you're going to probably conclude that 30 is 10 units from mu to the left, and then 50 is 10 units from mu to the right. Don't make the mistake of thinking in only one direction. The question is greater than 10 units from mu. That means distance. Just because it says greater doesn't mean you're only moving to the right, which is kind of a misperception that students have in this situation pretty frequently. It's really asking you, what's the proportion to the distribution outside of a radius of 10 units from the mean 40? So what we want is all the area that's greater than 10 units from 40. We can think of greater as being like an inequality. Watch what I'm going to write now. I'm going to rephrase this question. I'm going to write it in math language. So what we're going to have is we're going to have the absolute value of mu minus x must be greater than 10. Now that's another way of representing the same question in a little bit more concise mathematical language. Please remember, and go ahead and send me a comment below if you need this to be explained or you need some clarification, but because the distribution assumes a continuous distribution, we have a pure inequality here. The distance must be greater than 10, so we can use exactly 10 as our boundaries to the interval that we're solving for outside of it. And we're still going to get a correct answer because the difference between greater than and greater than and equal, there's no difference when you're talking about continuous data. Discrete data is different, but when it's continuous data, they mean the same thing. So I've placed it that way. So what we're going to have to do is find the z-score. Theoretically, you might feel like you want to find the z-score of both of these and solve that way. But I'm going to show you a little workaround. I'm going to solve the z-score of 50. And when I did it, I plugged it into the formula. You saw me do that a couple of times. I find that the z-score of 50 is 1.67 when I round appropriately. So that's the z-score of 50. So when I look that up on the table, now I know that I'm going to have a z-score of positive 1.67, and this must be negative 1.67, because after all, they are symmetrical, right? They're both 10 units from the mean. I found from the table that the area to the left of negative 1.67 is 0.0475. So again, you can always rely on the symmetry of the normal distribution. It's a good tool. If your distribution isn't symmetrical, it's not a normal distribution to begin with. So I can just go right ahead and accept that the area in this tail to the right is going to be equal. And that means that to get the answer to this question, we just need to multiply that by 2. That's going to be what? 0.0950, if I'm answering that correctly. And so that's actually the answer. If you wanted to do it a different way, you can actually solve for the area to the left of 1.67. It's going to be 0.9525. That's this whole area from here to here. And then you can, for example, this is not the most efficient way to do it, but if you wanted to do it this way, you'd get this area from this point to the left of 0.9525. You could subtract the 0.0475 from it, and then you'd end up getting the area in between those boundaries. And then you'd turn around and say to yourself, well, I know that the area of this entire thing is 1, so I would subtract that area between from 1, and you'd still get the same answer. So that's an alternative way to do it. If you haven't watched the Learning to Use the Z-Table video yet, go ahead and backtrack and you can watch that to see the setup for all this. And please send me any comments in the bottom if you have any questions, if you want clarification, and don't forget to like and subscribe. Thanks a lot.